Okay, this is a presentation of the last major process that the class was going to do, and a major process in its own, casting. Um, Casting is when you pour a liquid that's going to harden, maybe molten metal or um, a plastic that's in the process of hardening, and pour it into a cavity. And when it hardens, you take the cavity away and you have your part. You could make this example shows making a cup with deep drawing or mold casting. Most soft drink cans are made by deep drawing, taking a piece of metal, pushing it in, pushing dye into it. Um, but you could make a similar cup by casting it, by pouring material in. And so that seems kind of a weird thing to do. But if you were doing it in plastic, which is one way that plastic soft drink containers are made, is through injection molding, which is a similar to casting. Okay, you basically have one use molds or permanent molds. Actually, there's a sort of a category in between. What we would for plastics is a category in between, but um, expendable. You make one, you break it, and then go on to the next. Now you would be using the same pattern to make multiple parts, but you end up breaking each mold in green sand casting um, to um, for, let's say, an automobile engine block. There's a couple of other types that are fairly useful um, in industrial settings. Investment and lost wax, which really can kind of be the same thing. It's a way of making it can be made up into multiple parts um, multiple times, but you still break the outer housing, the mold itself, um, to get the part that you need. Permanent molding, um, injection molding is in plastics is a category of casting. In die casting, again, you take usually low temperature metals and force them into a steel cavity, pull the thing apart when they harden, and you've got your part. And these are some examples. And the single process assignment has um, a video on investment casting and injection molding and blow molding that you need to watch, because there will be questions about those kind of things on the um, final exam. You don't need to memorize all these different types, but understand that there are some other varieties that go in here. Let's get to some of the terms. The mold is the thing that holds the cavity. And the cavity is that empty space that you're going to pour the material in. The pattern is that original piece. And the flask is the thing that holds the mold. In the case of the sand casting that you'll see in the videos, um, the flask, the video of the home foundry, it's a wooden flask and puts the pattern in, puts the sand around it, takes the pattern out, you have your cavity, and keep those terms in mind. Once this is put together, a two-piece mold, um, should mention that you can do this with just one, but with a two-piece mold, you have made a place where you're going to have this mold cavity where the end part's going to be on the inside. You have your runner. Looks a little complicated. You'll see it when you actually watch the video, how it actually goes together. This is some of the equipment that we have here. The top photographs is kind of an overview of the sand casting area. We can't do sand casting in this class because it is a fairly complicated process. It requires, we just can't squeeze it in, which is why we do plastic casting, which I'll get to at the end of this presentation. But you have a pattern down there, which was a cannon. You notice it's in two pieces. It'll make some sense when you see the video, and you can see our flask, cope and drag, with a board in between, which is part of the process that you'll see. Okay, once you get your mold together, you have some areas of some other terms, and you saw it in some of the other pictures. You have a sprue, which is also a name for the place where you pour the material into the mold cavity, and you have a riser where the material escapes. You're aware, if you drink something with a straw, that if you have two things, water is going to find its own level of, it's going to find its main level. And so it's the same true with molten aluminum. It's going to fill everything and then come out to a level. It'll make some sense. You have gates, which is getting material in towards the cavity, and runners, which it's another, sometimes runner and sprue are interchangeable, where you pour it in. So here you can look at this cutout. Pour the material, the liquid in blue, into the mold. It flows down, fills that area, and then it'll rise up so that the level at the runner and the riser is the same. And if you know that you have material in the riser, then you know that you have material in the mold. This also shows a core. A core is something that you would place in your mold because you want to have an empty space. If you remember that cannon, that could be made where the main part where it's going to be shooting from could have a core in there, so that when you pour it, it has a place that you would then have to finish and drill out. You'll see some examples of that in the videos. A few other terms that are kind of important in designing with this. One is draft. It's not very successful to design things that don't have a little bit of a slope to it, because it makes it hard to remove the pattern or the part itself may have a problem. So you generally have stuff that angles in. You certainly can't go beyond 90 degrees, and you want to have 3 to 4 degrees of slope on any given side. The parting line is when you put the two pieces together, you inevitably a little bit of material will seep out in the place where the two halves joined, and that's called a parting line. And you also have to take into account that there's going to be shrinkage. This is really getting into pretty advanced casting techniques. So if you ever design anything to be cast, just keep in mind these particular items. There you can see an example of a parting line. That part on the top, the right half was, and the left half, the mold was in that area, and it's been sanded down, but that white line was the parting line. You can see an example of a core. It's just a very sad, it's a piece that's sand, but specifically with sand. And this is a picture of our furnace and the crucible inside. The crucible is the thing that actually holds the metal. And we've got all the equipment to pick it up and pour it out. Now, once you actually start pouring, you got to figure out the melting process. You've got a crucible in the furnace, and then slag that develops on the top of the aluminum, so you have to scoop it off. And with plastics, it's a little different. Is it a thermoset that's going to have to be, you have just a very quick amount of time to put it into an injection mold. You got to think about the solidification process, and then the part removal, break the sand mold, but then you got to scrape off all the excess sand. Then you got to actually cut away the riser and runners, and there's a whole lot of stuff that goes in there. And these patterns are kind of hard to, they take a little bit of abuse, and you got to make sure that they're not dropped on the floor, and if they are, that they're patched up, and all kinds of stuff that go into this and make it a very interesting process. Here's how we're going to do it, and there's a video that you need to watch, but we're going to do this with plastic casting. The aluminum casting is very, very time consuming, and barely have enough time to get you through the other processes. What we were going to do is form a cup, if you will, out of a sheet of plastic using a vacuum former. And each group was going to take all of their parts from the milling machine and screw them together, and one other part that gets threaded in. And that was going to be your pattern. And then the mold would be poured over the pattern, and then you would take that mold apart, and you would have you pour urethane into the mold. Here's what I'm talking about. When you assemble the little parts, you put them in this plastic container you would be making. Then you would pour the silicone mold over that part. And then you would, when you take that out, you would have a mold, the blue mold on the top left, where you would pour liquid plastic in, and it would harden, and you've got an example out there. Unfortunately, it's kind of a bad color. Some people made some of these, left them, and you get a chance to color them. But you can see one over on the right in use. Those slots happen to be the perfect size for USB to drop in and hold them in place. I will mention now that when we're back to somewhat normal operations, if you want to come in and do some casting or do some milling or do some welding, you can let me know, and we'll make arrangements for you to come in and do some extra work on your own. A little bit's going to depend on how things are planned in the fall, but we certainly can probably find time for you to come in and do some milling if you didn't get a chance to. Do some turning on a lathe. Do some casting. Here's a part that has come out of an injection mold, and you can see the sprue where the plastic is forced in and it goes down to the runners, and the gates is the part where it fits into the particular to the cavity, which gives you the part that you're going to use. Okay, these sites are also on the usual way of having videos to watch, and the first one is not a video. It is a site that has a pretty good terminology page, all the vocabulary of sand casting. The first of the sand casting examples is a guy that makes this stuff in his backyard. Backyard foundry. It's amazing. I'd love to have a wife that would let me do that. The second is the continuation of that. The first one is making the mold, and the second one is pouring the aluminum. And the last video here is actually from the Smooth On company that we use, their plastics. Smooth On actually is very big in the Los Angeles area because they use their products to make a lot of the masks, and they used it all to make all the masks in the Planet of the Apes movies, and a lot of the prosthetics that actors wear in movies is done with their plastic. Okay. Enjoy watching these videos.